talk about Tor, also known as the onion router. It's a web technology that lets you encrypt your traffic in a way that prevents others from seeing what you're doing on the internet. Most people think of Tor as the dark web, allowing you to access illegal stuff, but for the most part, Tor is being used by dissidents and people that are just concerned about their privacy. So we're going to find out how Tor works. So we're going to start by looking at how the internet works in general. So let's say you are this computer and your Comcast is your internet service provider. So you've got an IP address. In this case, we're going to pretend that it's 4.4.4.4. And Comcast is connected to the whole big fat internet. And there's a DNS server. And the DNS server is very, very, very important. What it does is it takes what we call URLs, which are human-friendly names, and it converts them into addresses. So, for example, google.com has a address of 1.1.1.1. The internet and computers, they don't know what google.com is. Google.com is only good for people to remember. The internet needs a number. It needs an IP address. So, let's say you want to visit google.com. You make a request to look up the address. So that goes to your DNS server, and your DNS server looks it up, figures out, hey, the address is 1.1.1.1, and it lets you know. So now you can call up Google. You can search for Toyota cars or whatever you're searching for, and your request goes to your ISP, and your ISP says, hey, he is looking for Google cars, and this is his IP, and it sends a request off to Google, and Google does its crunching, sends you back a car, and that's how it works. But obviously it's way, way, way more complicated than that. Anyway, the real problem with this whole thing is the Russians can see it all, and you don't want that. So, how do you keep the Russians from spying on you? And the answer is, you have to encrypt everything. And if you don't know how encryption works, in general, you can watch our video on encryption. But if you do, then what you need to know now, more specifically, how does the onion router work? So all over the United States and Canada and Mexico, we've got these nodes, which are basically computers and servers that volunteers have set up, and they handle the traffic for the onion router, and they're everywhere, and they're running 24 hours a day, and they're run by volunteers who believe in the network. So once again, we've got you sitting here in the corner, and your address is 4.4.4.4, and you're trying to access something on this web server, 1.1.1.1. And Comcast is your ISP. So when you use the onion router, you basically pick 3 nodes. So in this case, you're going to pick A, D, and G. And pick these at random, and you route your traffic through them to the web server. And you do it in a way that nobody knows what you're doing. And here's how it works. So every one of these servers, including Google, they've got a key, an encryption key. So you write a message to Google, and you're searching for Toyota, and you encrypt that message with Google's key, so only Google can read it. And you take that whole message and you figure out what key G has, and you encrypt the message, including the address, with G's key. So G knows to send the message to Google. And then you take that whole message and encrypt it with D's key. So D doesn't know you're searching for Toyota, but he knows that he has to send a message to G. And you take that whole message and you encrypt it with A's key. So A doesn't even know that you're searching for Toyota, and he doesn't even know about G. He just knows that he has to send a message to D. And this whole message gets sent to Comcast. So Comcast only knows that it needs to send a message to A. So your data flows like normal, through your ISP, through all the nodes, and to the web server. But at each node, a layer of encryption is removed. So when the data gets to A uses its key to unlock the first layer. And all it sees is there's an encrypted message, and I gotta send it to 6.6.6.6, which is D. And when it gets to D uses its key to unlock the message, and D thinks the message came from A. It doesn't know that it came from you anymore. And all it sees is, I gotta send this encrypted message to 7.7.7.7. And when it gets to 7.7.7.7, which is G thinks that it got the message from D. It doesn't know about you, and it doesn't know about A. And all it knows is, I've got to send this message to 1.1.1.1, which is Google, or whoever it is. And when Google gets a message, it says, hey, he's searching for Toyotas, and it thinks the message came from G. It doesn't know anything about you, or A, or D. So, the real question is, though, how does Google or some other hidden service hide itself from you? Because right now, Google doesn't know who you are, but you know who Google is. And you know Google's IP. And that's where you create an address that, instead of ending in the .com or .net, ends in .onion. So remember, we got all these nodes all over America. So you pick 3 nodes and you create a root. That's how Google hides. So in this case, it picked I, H, and G. Then it does it again. And then it does it again. So now it's got 3 roots. C, D, and G. We call those introduction points. And we give them addresses, because they've got addresses. So Google says, if you want to find me, I'm at C, D, and G. And it publishes what it calls the hidden service descriptor. And you're sitting around, you want to access Google. You got no idea what the address is, you just know C, D, and G. So again, you pick a root. Normally you pick 3 nodes, but I've only highlighted 2 for simplicity. So now you've got a root, and you connect your root to one of the random C, D, or G. You don't pick all 3, you just pick 1. So you're ending in A, Google's ending in C, D, or G. And Google tells you it's got a secret name, blah blah .onion, and you know where it is. And you want to send a message to blah blah .onion. So now you've got a root from A to D. So we're going to hide all the other ones. Basically, you know that Google's at D, and Google knows that you're at A, and nobody knows anything else because of the layers of encryption we talked about earlier. So your data flows like normal, and nobody knows anything. And remember, there's encryption everywhere. Every node's encrypted. So, can this be hacked? And can your traffic be detected? Absolutely. But the chances are pretty low. There's all kinds of crazy cryptography and analysis work that's being done, and in many cases website fingerprinting. And what that means is every website has a unique traffic pattern when it comes across the network, and even if it's encrypted and we don't know what it is, if you intercept somebody's data and there's a lot of data, you can run statistical analysis and try to figure out what they're doing. Object of another.